Good morning dear students, welcome to Maths Bridge course. So, in the previous classes we have completed trigonometry, okay, whatever the topics that are to be studied from the perspective of 11th and 12th, connecting your 10th syllabus, I have done it, okay, we have done that. And also I have also showed you how the 10th syllabus mathematics, that is trigonometry itself, will help you to solve some of the questions that have appeared in some national entrance exams like JEE mains and also some state entrance exams like EAPCET, AP EAPCET and Telangana EAPCET. So, that is why trigonometry is very important. It is a foundation of mathematics. That is why we started with the topic of trigonometry. Now, proceeding further, now we are going to start with the topic of sets and intervals. Wavy curve, it is a very important concept actually, which we will be learning in the next class. But in today's class, we will be learning the concept of what? Sets and intervals. Sets and intervals highly important because this is going to form the basic for you to learn the concept of functions. Learning the concept of functions is going to help you to do really well when it comes to the topic of what? Differentiation, integration, all the other topics, okay, because the functions that they are using is what? Modulus function, greatest integer function, that is also called step function, and also fractional function. To understand all this, you should know the basics of functions. To understand functions, you should know what is sets and what is internals. Not internals, it is intervals, and also you should know what is wavy curve method, okay, wavy curve method. So, today let us start with sets, okay. Let us start with sets. So, friends, if you look at this, so see here, if you look at this, sets means what? Sets means it is a collection of well defined objects or elements, it is called as a set. Collection of well defined objects or elements is called as a set. So, what is this well defined objects or elements? So, let me explain that. Suppose I take set A, it is denoted like this, it is denoted by flower bracket. See, these brackets are also highly important, okay, these brackets are also highly important, they denote various things, okay, they have various meanings, okay, each bracket has various meanings here. So, this set we represented with flower bracket, clear. Now, see here set A, if I write it like this 1, 2, A, okay, if I write it as what? Apple, let me write apple. So, see here the elements of set A are what? 1, 2, small a and apple. Are they well defined? Yes, they are well defined. That means what? They are not going to change irrespective of the place and time, irrespective of the place and time, across space and time, or across what is it? Or across the location, it is not going to change. That is, one will remain one even in India, one will remain one even in Pakistan, one will remain one even in US. Correct na? Same thing, apple, we call it as apple itself even in India. Of course, different local names will be there. Apple varieties will be there, but apple is apple even in Telangana, even in Hyderabad, or even in what is it? Even in Andhra Pradesh. Apple is apple even in Kashmir, and apple is apple even in New York. So, that means what? They are universally accepted. That means they are what? Well defined objects. They are well defined objects. Small a, it is small a even in US, small a even in Europe. That is what we accepted. This is universally accepted. That is the meaning of well defined objects. Now, what are those that are not well defined? Suppose let us take set of B. If I take set of B, okay, if I take it like this, if I say bad bowler, if I am talking about cricket, bad bowler, okay, if I take great Sachin, if I say great Sachin, if I am talking about great Sachin Tendulkar, great Sachin, set of this. So, bad bowler, okay, bad bowler, that means what? This is what? This is adjective, this is adjective, great Sachin Tendulkar, or this is also what? This is also adjective, in English we call it as adjectives. This is what? Bowler, Sachin, they are all what? Noun. So, I am not taking English class, just I am explaining here. So, see here bad or great, it is defining the noun, it is defining the noun or characteristics of the noun. So, that means what? This bad and great, they are called adjective. So, these adjectives are very subjective. That means what? A person may be called a bad bowler here, but in some other place that person may be a good bowler. In one match he may be a bad bowler, in some other match he may be a good bowler, and for some batsmen he may appear as a bad bowler, for some other batsmen he may be a tough bowler. So, it is what? It is an adjective, it is not certain, or it is not an objective criteria. That means it is not well defined. So, it is very subjective, it is very subjective. So, it is not well defined, not well defined. Now if you talk about great Sachin Tendulkar, if you talk about, so great. So for us Indians, Sachin Tendulkar is great, but if you go to Pakistan or if you go to some other country and ask, they will say their country cricketers as great. So this is also subjective. This is also subjective. That's why this is also not well defined. So B is not a set because it is not containing elements. It is containing elements, but it is containing elements which are not well defined. That means B is not a set, but on the contrary, A is a set because 1, 2, A, apple. These are universally well defined. These are universally accepted. Wherever you go, apple is an apple. It is not going to change. 1 will be 1. Okay, suppose I write set C, PQR. PQR. Okay, if you go to Pakistan or if you go to Afghanistan, even if they have studied or not studied, PQR is PQR only for them. Okay, PQR is PQR only for them. It is same in China. It is same in Australia. So PQR is PQR only. It is not going to change. That is the meaning of what? Well defined objects. That is the meaning of what? Well defined objects. So this is the meaning of sets. So first thing you should understand what? It is a collection of well defined objects. Now let us proceed further. I hope it is clear what is a set now. With some examples I have told you what is a set. What do you mean by well defined objects? Now sets can be represented in two forms. Okay, one is roster form, another one is set builder form. One is what? Roster form, another one is set builder form. So what is this roster form? In roster form, elements are written directly. Okay, that means what? Suppose I take set A or set B, elements are directly visible to you. You don't have to decode the elements. Elements are directly visible or directly written. If I write it like this 1, 2, 3, 4. So this is having what? This set A is having the elements 1, 2, 3, 4 are the elements of set A. Set B, if I take it, if I write it like this P, Q, R, S, T, U. Okay. So these are all what? Elements of set B. The elements are directly visible. They are directly written. Then you don't have to deduct or decode from anywhere. So that is the meaning of what? Roster form, where the elements are directly visible or the elements are directly present. I can say elements are directly present. Directly present. See, for some students in the high school itself you might have learned set, but it's okay. Let us revisit the concept and understand it in a better way. Okay. So this is what? Elements are directly present. Now what is this another form? That is set builder form. What is this? Set builder form. Elements are not directly present. You have to decode it. You have to what? You have to decode it. Okay, let us take an example. So let A be a set such that X, where X belongs to, A be a set of X where X belongs to, what is it? Let me take it as natural numbers. Okay, natural numbers, like this we will write it, natural numbers such that what I can say, X is greater than or equal to 1 but less than or equal to 5. Okay, X is greater than or equal to 1 but less than or equal to 5. So A is a set of X where X belongs to natural numbers such that X is greater than or equal to 1 but less than 5. So based on this you can definitely decode the set, but directly the elements are not present. From here you have to decode. You have to decode or deduct the elements. Deduct the elements of which set? Set A. Elements of set A. So A can be written as what? If I put X is less than or equal to 1 or X is greater than or equal to 1 but less than or equal to 5 means it can contain 1. It can contain the numbers from 1 to 5. That is 1, 2, 3, 4, 5. So these are what? These are the elements of set A. Now this is of which form? Roster form. So from set builder form we wanted to roster form. Now we got the set A. Okay, now we got the set A. So X is a set of all natural numbers. Now see here, let us take one more set. Set B. Set B is a set of X such that where X belongs to let us take X belongs to whole numbers, where x square minus 4 is less than or equal to 0. X square minus 4 is less than or equal to 0. Okay, this is the condition that they have given, where x square minus 4 is less than or equal to 0. Now we have to deduct the elements or decode the elements. So what we will do? X square minus 4, this is of which form? A square minus b square form. So I can write it as what? X square minus 2 square is less than or equal to 0. So further I can write this as what? I can write this as x minus 2 into x plus 2 is less than or equal to 0. That means what? X minus 2 into x plus 2 is less than or equal to 0, because why? A square minus b square can be written as what? A plus b into a minus b. This gives me what? X minus 2 is less than or equal to 0 means I will get 2. What is this? X plus 2 is less than or equal to 0 means I will get it as minus 2. So since it is less than or equal to 0, we will write it as a closed bracket. About this, I will be talking about this when I talk about the intervals. So we will write it like this, minus 2 to 2, we will write it. So all the numbers that are between minus 2 to 2 and including minus 2 and 2, are the elements that are present in set B. So set B can be written as what? This implies set B can be written as minus 2, minus 1, 0, 1 and 2. Okay, that is the meaning of this closed bracket or the square bracket. So it is including all the elements from minus 2 to 2, including minus 2 and plus 2. Okay, but if I am writing open bracket, that time what happens is, it is including all the elements between minus 2 and 2, but excluding minus 2 and 2. So about this I will talk in detail when I talk about intervals. Clear? So this is how we have set builder form. So let us take one more example. For set builder form. So see here, let C be a set such that X is a set of all integers. We write integers like this. We write it like this. Okay, set of all integers, or we will write it in like this. Set of all integers. Okay, such that where, okay, x minus 1 into x minus 3 into x minus 4 is equal to 0. So we have to deduct from here. We have to deduct the value of x. That means what? We have to deduct or decode the elements of set C. So directly elements are not given. So that is why it is called as what? Set builder form. So C is equal to what? If I equate to 0, x I will get it as what? 1, x I will get it as what? 3, x I will get it as what? 4. So these are the elements of set C. 1, 3, 4 are the elements of set C. These how you will decode. Okay, in most of the questions when you see in the competitive exams, be it in JEE mains, okay, in EAPCET, EAPCET, KCET, whatever exams, directly they will not give the elements, they will give it in set builder form. You have to decode it and get the elements like this in the form of roster form. Clear, friends? So till now what we studied, what is a set we studied, and we studied how a set can be represented. One is roster form, another one is set builder form. Now let us study about some types of set. Okay, types of set. So here first thing what we have is empty or null or void set. The word itself indicates empty or null or void set. So suppose I represent A like this. Like this. I told flower bracket we used to represent a set. If nothing is written means it is having no elements. Number of elements here is 0. Okay, that means what? It is having no elements. Or empty set or null set or void set, it is not having any elements. Okay, we call it as what? We call it as what? Null set. Okay, so we will write A as equal to what? 5. A is equal to what? 5. Here this is nothing about what? 5. PHAI. Okay, this 5 represents what? Null set. How do you indicate a null set or empty set or void set? Void set we represent it as 5. Suppose I say C is an empty set, I can write C as what? Equal to 5. Okay, if I say D is an empty set, I will write D equal to what? 5. Okay, this is what? This is denoting a null set or a void set or an empty set. 5 is denoting that. So if I write A flower bracket nothing is written means it is nothing but it is denoting 5. That means it is denoting empty set or null set. Clear? Okay. Now singleton set. What is this? Very simple. So singleton set A, B, C. Singleton set means what? If I write it like this, in singleton set, okay, you are having only one element. That is called a singleton set. So suppose I write it like A here, let this be 2 here, let this be some random, let me take some T. Okay, singleton set can be any set which is having only one element. That is called as a singleton set. Okay, that is called as a singleton set. A is equal to small a, B is equal to 2, B is equal to T. This is what? Singleton set. Now tell me, if I ask a question, D is written as like this, 0 is there. Is this a singleton set or is it a null set or it is having how many elements here? This is my question. See here, 0 is there. Okay, 0 is there. 0 is also an element. Correct na? 0 is also a number, it is also an element. That's why this is a singleton set. You cannot say this is a null set. Here you are having an element. This is not denoting the number of elements. Okay, here you are having an element. This element is 0. But the number of elements is what? 1. Number of elements here is what? 1. So number of elements in singleton set will be equal to what? Will be equal to 1, but whereas here it will be equal to 0. Okay, here we are having what? D is equal to at, it is representing a set having 0 as the element, but the number of elements is what? 0 is also an element, that means what? 1. Okay, so number of elements here is 1, so that means what? This is a singleton set, this is what? This is a singleton set. Clear? This is a singleton set. Now suppose one more example, if I write E is equal to, if I write it like 5, okay, if I write it like 5, is this a singleton set or a null set or a void set? What is this? This is my question. Okay, E is equal to 5, see here, this is not an empty set or a null set, this is what? This is a singleton set having an element 5, so this is also a singleton set. This is a singleton set. See, if I write set A without nothing, okay, without anything here, that is null set. Null set is represented by 5. But inside this, if I write 5, so here I have written 5 inside this flower bracket. That means what? 5 is an element. So here the number of elements is what? Here the number of elements is not 0, because 5 is an element. Here the number of elements is 1. So this is a singleton set. Clear, friends? Understood the difference between void set or null set or empty set and singleton set? Singleton set, number of elements are 1. It can be any element, 5, 0, minus 1, anything. But when it comes to void set, it is having a flower bracket, within it nothing is there. That is known as what is that? Void set, null set or empty set, where the number of elements is 0. This is the difference. Basic difference is what? Number of elements is 0 here, the number of elements is 1. Clear. Next one. So well-known sets means here N is representing what? It is representing natural numbers, that is from 1 to 3, it will go on up till infinity. Natural numbers. So we will represent it in set form. We will write it like this. W, this is whole numbers. So this is what? It is starting from 0, 1, 2, 3 up till infinity. Okay, up till infinity. Clear, friends? That is, we are representing the whole numbers. Now when it comes to this Z, see Z will write it usually like this or like this. Okay, this is what? This is a set of integers. That means 0, 1, 2, 3, that positive numbers. Along with that we have negative numbers. That is, I can write what? Minus infinity, minus 2, minus 1, 0, 1, 2, 3 up to infinity. This is what? Set of all integers. Okay, now proceeding further, this Q, this is Q, we represent it like this in set form, we represent it like this. R will be like this, Q will be like this, R will be like this. C, this is complex numbers, we represent it like this. So Q means what? This is rational numbers. Q means what? Rational numbers. We are representing set of rational numbers. It is written like this, where x is equal to p by q, such that okay, q belongs to what? Q belongs to integers. Q belongs to set of integers where q is not equal to 0. Okay, so x can be written as what? P by q, where q is an integer, q belongs to an integer, and q is not equal to 0. This is representing rational numbers. This R by q. This R by q means what? This R is real numbers. This is q is rational numbers. So R by q means what? It is representing R minus q. So this is what? Real numbers. From that, if you remove rational numbers, from real numbers, if you remove rational numbers, what you will be having? You will be having irrational numbers. You will be having what? Irrational numbers. So this is what? Set of all irrational numbers. This is representing. Okay, irrational numbers, how you will represent? Okay, where x will not be equal to p by q. Okay, where x will not be equal to p by q, that is irrational number. Here x is equal to p by q. Okay, where q belongs to integer and q is not equal to 0. Here x you cannot write it as p by q form. That is, x you cannot write it in rational form. X you cannot write it as p by q form, but still q belongs to integer, where q belongs to integer and q is not equal to 0. Okay, most important thing is what? Q is not x cannot be written as p by q. Clear? Next thing, observe here, set of all real numbers. Set of all real numbers means what? Set of all real numbers means it is having rational, okay, plus irrational number. Okay, rational plus irrational numbers. Rational plus irrational numbers. That means what? This is rational number, this is irrational number. That means what? I can write Q union, this is what? This is Q, this is not 5, this is I can write it as, see here, Q, okay, Q union R slash Q, okay, I should write slash like this, R backslash, okay, backslash Q. So this is what? Rational numbers, this is irrational numbers. Union of rational numbers and irrational numbers gives us what? Real numbers, gives us what? Real numbers. Now coming to this complex numbers. Complex numbers is a chapter that we will be studying in 11th standard and 12th standard. Continuity of that, continuity of what? Complex numbers is a continuity of quadratic equations. That will also be done in the bridge course, don't worry. So complex numbers means what? You can represent the complex numbers what? As what? P plus IQ. P plus IQ, you can represent it as P plus IQ. Okay, you can represent complex numbers as what? P plus IQ. That is what? I is what? I is an imaginary number. That I is represented by what? I is called an imaginary number. I is called as what? Iota. Okay, it is an imaginary number. Its value is equal to square root of minus 1. Okay, about this I will explain while we discuss about quadratic equation and complex numbers in the bridge course itself. So P plus IQ we can represent. Complex numbers are represented as what? P plus IQ. Suppose for example, like if I write 3 plus 2i or 3 plus I2. Okay, if I write 2 minus I2. So these are all what? Complex number. This is real part and imaginary part. Okay, we are having real part and imaginary part such that P comma Q belongs to set of real numbers. P comma Q belongs to set of real numbers. Clear friends? So till now we studied what? Some various well known sets. That is, first we studied natural numbers, whole numbers, then integers, rational, irrational, real numbers and complex numbers. So all these things together can be represented under one umbrella. Okay, that is, let us see here, that is under one figure you can represent. So see here, suppose this is a circle. Okay, this is having what? Set of all complex numbers. Set of all complex numbers. Within this comes set of all real numbers. Set of all real numbers. This is set of all real numbers. This is set of all real numbers. In the set of all real numbers, what happens is the set of all real numbers observe here. In the set of all real numbers, what happens is you have to observe. Okay, let us take some other color. It will be divided like this. In the set of all real numbers, what happens is, see here, let me write this R outside. This will be set of all real numbers. Under the real numbers, it is divided into two parts. One is called rational. This is complex number like this. This is rational real numbers like this. One is rational number which we represent it as what? P by Q. Another one is R slash Q. That is what? This is irrational. This is rational number. This is irrational number. This is rational number and irrational number. Within the rational number, we have what is that we call? Within the rational number itself, we have something called, within the rational numbers itself, we have some more divisions. We have something called integers. Correct now? We have something called integers. And within the integers itself, we have something called what? Within the integers itself, we have something called whole numbers. Okay, whole numbers. Whole numbers, that is what? Integer which is having 0, which is starting with 0 and positive numbers. Within the whole numbers, we have something called, what is that? Natural numbers. That is something called natural numbers. Okay, so see here what happens when it comes to natural numbers. Observe here carefully. If you eliminate from whole numbers, what you get is natural numbers. So this is how you can represent. First is complex numbers, within that comes real numbers. In real numbers, we have rational and irrational. In rational, we have further division, subdivision, that is integers. Within integers, we have what? Whole numbers, and we have what? Natural numbers. So clear friends, this is how we will write it. So this further I can represent it as what? So natural numbers are proper subset. What is subset or proper subset? I will tell you. Natural numbers are subset of whole numbers, and whole numbers or all whole numbers are subset of integers. Okay, integers, and integers are subset of what? Rational numbers. Okay, rational numbers, and rational numbers are subset of what? Real numbers, and real numbers, all real numbers are subset of what? Proper subset of complex numbers, proper subset of complex numbers. Clear friends? So we will write it. This is representing subset, this is representing subset. So I hope it is clear. Let us proceed further. So I was talking about subset. So let me explain subset here now. Suppose we are having a set A. Suppose we are having a set A. If it is having the elements 1, 2, 3. If it is having the element 1, 2, 3. So what are its subsets? What are the subsets? For any set, the null set phi is also a subset. The null set phi is also a subset. So what are its subsets? First thing is what? Phi is one subset. Okay, this phi is one subset. Then singleton sets, 1 is a subset, 2 is a subset, 3 is a subset. Okay, then combination of two numbers. If I write 1 comma 2 is a subset. Okay, 1 comma 2 is a subset. Then what we are having? 2 comma 3 is a subset. Then what we are having? 1 comma 3 is a subset. Then the set itself is a subset of itself. The set 1, 2, 3 is a subset of itself. Okay, so we are having what? 1 comma 2 comma 3 itself is what? Subset of itself. So these are all the subsets. How many subsets are there? 1, 2, 3, 4, 5, 6, 7, 8. So if they ask you how many subsets are there, if the number of elements are what? Number of elements 1, 2, 3. Number of elements is 3. If they ask number of subsets is given by what? 2 to the power of n. 2 to the power of n of a. 2 to the power of n of a. 2 to the power of n of a. There n of a is what? N of a is what? Number of elements of set A. Number of elements of set A. So if you talk about this set A, how many elements are there? 1, 2, 3. 3 elements. So number of subsets will be what? 2 power n of a is what? N of a is 3. 2 power 3 we are having 8. So that is what we have 1, 2, 3, 4, 5, 6, 7, 8. So that is known as, what is this? Number of elements of A is what? Number of subsets is what? 2 power number of elements of A, that is 2 power 3, we are having 8. Clear? Now we have something called proper set and improper set. Okay, proper set and also we have improper set, which is not that important, but I will explain. Proper set and improper set. So what is this proper set? See, proper set, it is denoted by like this. Okay, it is denoted like this. It is denoted like this. Improper set, it is denoted like this along with equals. Okay, so proper set means what? It is having all the subsets except the set itself. Okay, A is a subset of A itself, that is we have to remove this. So here the proper subset means we have to write down everything. We have to write down everything what we have as a subset, that is 5, okay, 1, 2. Let us understand through this example only. 1 comma 2. I am talking about this for this set itself. For this set itself, you have to write down all the subset that we have got. 2 comma 3, 1 comma 3, everything we have written. But except this, except what is this? This one. We have not written this one here. This is not written here. This is not written here. Okay, this you should not write here. So that means what? So proper subset is a what? Proper subset is a subset of all the elements, but it is not having subset of A, F, subset of A as itself. Subset of A as itself, that is 1, 2, 3 cannot become a subset of 1, 2, 3. That is set A cannot become a subset of itself. Set A cannot become a subset of itself. That is known as proper set, proper subset. So proper subset will have all the elements except this. Same thing what you have written 1, 2, 3 should be not there. That's all. That is a simple thing you have to remember. Now what is this improper set? From the subset, if you remove proper set, you will get improper set. That means what? I should include what here? I should include what here? I should include 1, 2, 3. I should include 1, 2, 3. Okay. If I include 1, 2, 3, or in some books you can also include 5. They will also include 5. They will also include 5. Okay. So 1, 2, 3. So these are what? Improper set. Not that important, but in some questions they may ask proper set, improper set. In some questions they may use these words. So that's why you should be aware of it. Okay, so if I talk about this one is what? One is a subset of A. If I talk about this 1, 2, 3, this is what? This I will write it as what? Proper subset. Proper subset. Proper subset. Now what about this 1, 2, 3? This 1, 2, 3 is also a subset of A. Okay, but it is also equal to A. So this is proper subset. This is improper subset. This is what? Improper subset. This is improper subset. Okay, so I hope it is clear now. We learned what is a set, roster form, set builder form, and we learned what is subset, and we have some well known sets, natural numbers, complex numbers, all these things, natural numbers to complex numbers. Then we learned what is subset, proper subset, improper subset. Now let us proceed further, friends. universal set. Universal set. So what is this universal set? So let us take set. Let us take the set U given by 1, 2, 3, 4, 5, 6, 7. Okay, let us write it like this. So the U is representing some set of elements. Okay, set of some elements. Okay, so let me write set A, set B, set C. Set A I will write it as 1, 2. Set B I will write it as what? 3, 4, 5. Set C I will write it as what? 6, 7. Okay, so like this I have written. Now if you talk about this universal set, it is like a elder brother to all of this. It is like a elder brother to all of this. So what I can say? So what I can say? A is a subset of U. Okay, B is a subset of U. Okay, C is a subset of, that is proper subset. C is a proper subset of U. Correct na? So I can say what? Instead of saying every time subset, proper subset, I can say what? U is the universal set. U is a universal set of ABC. U is a universal set of ABC. And also here also you should remember this word universal set, this is also subjective. This is also universal set is also subjective. So if I say U is a universal set for whom? That we have to specify. That's why I have written universal set of ABC. Just if I write universal set, you cannot say. Suppose I write here D is equal to, if I write 8, 9. Okay, 8, 9. What about this? If I said just say U is a universal set of all, you cannot say, because U is a universal set of only ABC. See here the elements 8 and 9 are not present in U. These elements 8 and 9 are not present in U. So that's why the word universal set is also subjective. So to make it objective, what you should do? Universal set of whom? ABC you have to mention. Clear? Let us proceed further. Complement of a set. Okay, complement of a set. So what do you mean by this? So what do you mean by complement of a set? So observe very carefully. Complement of a set. Suppose A is a set. We represent its complement. How do we represent? So see here. Complement of a set. See here we represent it as A to the power of C like this, or we can also represent it as A dash. Okay, we can also represent it as A dash. Oh, so let us take an example. Universal set, let it be like this: 1, 2, 3, 4, 5. Let there be set A. Let there be set A given by what? 2, 3, 4. Let there be set A given by what? 2, 3, 4. Okay, complement of a set or A complement. Okay, complement of a set, I can write it as what? A to the power of C or A dash. A dash is equal to A complement. I can write it as what? This is nothing but, okay, so that is nothing but what? A complement means you have to have the elements which are not present in set A. So see here, so that means what? From the universal set I have to remove what? From the universal set I have to remove what? Set A. From the universal set I have to remove set A. That means what? What I will be getting? So from the universal set, what are the set things that I have which are present in set A? 2 is present. Okay, here also 2 is present, 3 is present, 4 is present, 4 is present. So what is left out? Only 1 and 5. So 1, 5 I will write it. So A complement means from the universal set if you remove set A. So the difference of universal set and set A, it is nothing but what? It is nothing but A complement. Okay, it is nothing but what? A complement, fairly simple concept. So A complement means what? From universal set you will remove all the elements that are present in set A. So here you will get what? 1, 5 in this example. Suppose if you take the example like this, universal set is like this. Okay, that is having the elements 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Okay, out of this 2, 3, 4 are belonging to set A. Okay, then the remaining, this is what? Universal set, this is set A. The remaining, this 1 and 5, they are what? A complement. That is from U if you remove this, what we are getting? That is nothing but what? A complement. Okay, from if you remove A, what you are getting? That is nothing but A complement. Clear? Okay, fairly simple concepts. Okay, but before we go to complement of a set, we should know what is difference of a set. What is difference of a set? Difference of a set. Difference of sets. Difference of sets you must know definitely. So here difference of sets. So what do you mean by this? That is nothing but two sets A and B are given, means the difference of set means A minus B, that is what you will find out. But what is that? Not simple as not like natural numbers how you find the difference. Here you should know some basics. So suppose set A is given by 1, 2, 3, 4, 5, okay, and set B is given by 2, 3, 5. Set B is given by what? 2, 3, 5. Now they will ask the difference of sets. So A minus B they will ask. Okay, A minus B they will ask. Let me take one more set C. Let me take one more set C. Okay, 1, 2, 3, 4, 5. Okay, let me hide some more elements. 6, 7. 6, 7. Let there be set C, which is having the elements. 1, 2, 5, 6, 7. 1, 2. Actually, let me take it as what? Is having the elements 1, 2, 5, 6, 7. 1, 2, 5, 6, 7. Now let us do A minus B. A minus B means what? A minus B, okay, can also be written as what? A minus, okay, A minus A intersection B. Okay, or it can also be written as A minus A intersection B, or I can also write it as what? A minus B complement. So A minus B means what? So A minus B means what you have to do is, okay, compare set A and set B. Compare set A and set B. Okay, out of that you have to remove the elements that are present in B, elements of B that are present in A, elements of B that are present in A, elements of A that are present in B. Okay, elements of see A minus B. Let us understand again. So A minus B means what? A minus B means B elements which are present in A, you remove it. That is what it is the meaning. And what you should write? The remaining elements that are present in set A. So 2 is present, 2 is present, 3 is present, 3 is present, 5 is present, 5 is present. So remaining elements are what? 1. Okay, 1 is there. Okay, what is there? Apart from 2, 3, 5, what are present here? 1, 4, 6, 7. So A minus B means what? So remove the elements that are present in B from set A, remaining elements that are present in A. Remaining elements that are present in A, you should write what? Remaining elements that are present in A, you should write it. So that means what I should do? That means I should write what? That means I'll write what? This set be having like this. 2, 3, 5. Okay, let me have 9, 10. 9, 10. So see here, this will become what? This will become 2, 3, 5 is there here. Okay, so you have to remove the elements that are elements of B that are present in A, and you have to write the remaining elements that are present in A. So 2, 3, 5 if you remove, what are present in A? 2, 3, 5 if you remove, you are left with what? 1, 4, 6, 7. 1, 4, 6, 7. This is the meaning of what? A minus B. This is the meaning of what? A minus B. So let us use one more example. If I write B minus A, what will happen? If I write B minus A, this is nothing but what? B minus again A intersection B. That means what? What is common between B and A, you remove it. Here also, what is common between A and B, you remove it. And whatever the elements that are left over after removing the common elements, what are the elements that are left over in A? Because this is A minus B. So what are the elements that are left over in A, you write it as the answer. Now B minus A. Now what is common between B and A, you see. Okay, what is common between B and A, you see. Okay, remove that common elements. Then whatever is left over in which set? Set B, because you are subtracting some from B. So from whatever the elements that are left over in B, you write it. So this will become what? So what I should write? What are the common things between B and A? Between B and A, what are the common things we are having? 2, 3, 5. Okay, 2, 3, 5. Okay, 2, 3, 5. So 2, 3, 5 you remove. 2, 3, 5 you remove from where? You have to remove from B. So what are the things that are left over in B? You should write as the answer. What are the things that are left over in B? That is 9 and 10 are left over. 9 and 10 are left over. That you will write as the answer. That is the meaning of B minus A. So remove the common things and write the elements that are present in the first set, that is set A, when it comes to A minus B. So here remove the elements that are common between A and B and write the remaining elements that are present in first set, that is the first set here is what? B. The first set here is what? B. So let us take one more example, that is if you do what? If you do B minus C. If you do B minus C, first look for common elements between B and C. First look for common elements between B and C. Between B and C, what are the common elements we have? 2 is there? Yes, 2 is there. 5 is there? Yes, 5 is there. What else is there? 2 and 5 are there. Only 2 and 5 are there as common elements. Only 2 and 5 are there as common elements. So if you look at this, only 2 and 5 are there. So remove the common elements and write the remaining elements. Write the remaining elements of which set? Set C or set B? You should write the remaining elements of set B, because set B is having these elements, because it is B minus C, not C minus B. So set B is having what are the elements? Remaining elements are 3, 9 and 10. 3, 9 and 10. 3, 9 and 10. Okay, 3, 9 and 10. Now will you be able to tell me the value for C minus B? Will you be able to tell me the value for C minus B? So C minus B means what? So look for common elements between C and B. C and B common elements are what? 2 and 5. And you have to write the remaining elements. Remaining elements are what? Remaining elements of what? Remaining elements of C. So remaining elements of C are what here? After removing the common elements, 1, 6, 7. 1, 6, 7. Got it? 1, 6, 7. So this is how you represent it. This is the meaning of difference of sets. So suppose I take this first two example, first and second example, if I take it, for this if I want to write a Venn diagram, if I want to represent a Venn diagram, if I am writing A minus B, if I am writing A minus B, suppose A minus B we are having like this, A minus B we are having like this. So A minus B means what? Remove all the common elements, this is common elements, and also remove set B. Now whatever is left over will be the answer. Whatever is left over, I will represent it like this. Whatever is left over, I will represent it like this. So this is A minus B. Similarly, if I want B minus A, B minus A, B minus A means, see here this is set A, this is set B. Again, this is what? Observe here, this is set A and this is set B. Now remove the common elements. So first remove the common elements. So common elements will be removed from here, and also whatever is in set A will be removed. I want only the remaining elements that are present in set B. B minus A means I should need only things that are present in set B. After removing the common elements, these will represent it. Clear? I hope it is clear to all of you. Let us proceed further. Before intervals, we have to discuss about one more thing, that is symmetric difference. There is something called symmetric difference. What is the concept? Symmetric difference, friends. First we learned the normal difference, now we have to know the symmetric difference. In some questions they will give symmetric difference. Symmetric difference. Symmetric difference. Symmetric difference. So symmetric difference means what? We represent it as A delta B. Okay, A delta B. A delta B is given by what? A delta B is given by A union B minus A intersection B. A union B minus A intersection B. This formula can also be written as A minus B union B minus A. A minus B union B minus A. Okay, A minus B union B minus A. So let us take an example. Let there be set A represented by the elements 1, 2, 3, 4, 5, 6, 7. Okay, let there be set B represented by the elements 2, 3, 5, 6, 2, 3, 5, 6, 2, 3, 5, 6. Now they are asking A delta B. A delta B means what? Symmetric difference. So symmetric difference means what? What you will do? So symmetric difference means, so see here, see here, what you will do is in symmetric difference means A minus B union B minus A. So symmetric difference means what? So set A you will take, set B you will take. So symmetric difference, how do you represent? So see here, there will be set A and there will be set B. Okay, there will be set A and there will be set B. What you will do in symmetric difference means whatever the common things you will remove, whatever the common things you will remove, and whatever is left over in both the sets, whatever is left over in both the sets you will write it. Whatever is left over in both the sets you will write it. So this is set A, this is set A, this is set B, symmetric difference of A delta B. So see here, now if I want A delta B, see here A delta B, if I want whatever is common between these two, whatever is common between these two, suppose this is set, this set is having the elements like this 2, 3, 5, 6, 9, 10. Okay, so whatever is common between A and B, you see, if I see the common things, 2 is common, 2 is common, 3 is common, 3 is common, 5 is common, 5 is common, 6 is common. So whatever is left over in set A and set B, both set A and set B, we will write it as what? Symmetric difference. So I used to write what? A minus B means I used to remove whatever the common things, I used to write whatever the elements in set A, or B minus A means I used to remove the common things, I used to write whatever the elements that are left over in set B. But now you have to write the leftovers of both set A and set B. So what you will write it here? So you remove the common things. What is left over now? 1 is left over, 7 is left over, and that is in set A. Set B, what is left over? 9 is left over and 10 is left over. So this is the meaning of symmetric difference. Clear, friends? This is the meaning of symmetric difference, friends. Clear? So this is the difference of symmetric, this is the meaning of symmetric difference. Okay, clear? Symmetric difference means this is the thing. So you remove the common things and you write down in both the sets whatever is left over. Earlier what you used to do, you will remove the common things and you write the leftover from one of the sets from where you are subtracting, that's all. Clear? So this is the meaning of symmetric difference. Now let us go to some concept called, that is power sets. Very important concept, power sets. Power sets. Okay, power sets. Observe this. So power sets. So let us explain through an example. Let me explain to you through an example. So 1, 2, 3. Suppose set A is given as 1, 2, 3. What are the subsets to this? 5. Okay, 5. 5 is one subset. 1 is one subset. 2 is one subset. 3 is one subset. 3 is one subset. Then 1, 2 is one subset. 2, 3 is one subset. Okay, and what about this? 1, 3 is one subset. 1, 2, 3 is one subset. Okay, 1, 2, 3 is one subset. Okay, if I write this power set of A, if I write it as set of all these subsets, okay, power sets is a set of all, set of a subset of subsets of A, set of subsets of A, set of subsets of A is called power set. Set of subsets of A, we call it as what? Power set. Okay, set of subsets of A, we call it as power set. See, if suppose a set A is there, further if you are having numerous subsets, then set of subsets of A, we call it as what? Power set. Okay, if we write all the subsets and we write it as a single set, under a single set, that entire set we call it as what? Power set. That entire set we call it as what? Power set. Clear? That entire set we call it as what? Power set. Clear? That entire set we will be writing it as what? Power set. Now, now let us proceed further. If they ask, see here, okay, suppose there is set D, it is an what? Null set. That means what? It is having 5 value. Okay, it is having 5 value. If they ask you power of D, if they ask you power of D, if they ask you, first you write what? Power of D. Power of D means what? Power of D means this subset, I should write it. Subset of this is what? Just 5. Just 5. Just 5. Okay. Power of D is what? Just 5. Now, power of D, we have first I will do what? P of D. Now, I will do what? P of D. For this, I will write the subset. For this, I will write the subset. So, for this, if I have to write the subset, okay. So, this will become what? This will become what? Power of D. See, first observe carefully. Power of D means I will write what? First, power of D, I will write it. That is nothing but what? 5. Okay. This subset is what? 5. Okay. This subset is what? 5. Because nothing is there means 5 itself will be the subset. Now, power of D. Power of D means nothing is there means I should write what? First 5. Then this element. That I can write it as what? Power of D. Power of D will become what? See, if I treat it as A, if I treat this as A, this will become what? This will become 5 subset of A. This is what I will have, power of A. So, this A is nothing but what? This A is nothing but 5 here. This A is nothing but set of 5 here. So, this will become what? This will become 5 set of 5, this entire thing under set. So, power of D I will get it as what? 5 set of 5. 5 set of 5 I will get it. Okay, 5 set of 5 I will be getting it. Now, similarly, if I want power of D, 3 times power of D, 3 times power of D. So, see here the number of elements is what? 1. Here the number of elements is what? Okay, 1. Here the number of elements is what? 2. Okay, here the number of elements is what? Here it is what? 1. Here the number of elements is what? 2. Okay, here the number of elements is what? 2. Now, see here power of D. So, I am having what? Power of D. First I should find what? Power of D. Okay, then I should find this power of D, then I should find power of D. So, power of D. So, see here, observe carefully. Power of D is what? Power of D is nothing is there means null set. So, this will become what? Power of D is 5. First thing, this one. Now, I want to find out what? Power of D. Okay, power of D. Power of D. Just a minute. Power of D. I want to find out this. So, power of D I want to find out. Power of, this is what I have to find out now, this one. Power of D I have to find out. So, already I have 5, I will treat it as A. So, this will become what? Like this, already I have done this, so I will write it directly. 5 set of 5, 5 set of 5 I will write it. Now, I want to find this one, entire thing, power of D. Okay, this one I want to find out. Okay, so I want to find out this entire thing. So, see here, let me treat it as x and y. x and y if I treat it, first set what I'll have, I will have a null set. I'll write it as what, 5. Then I'll write what, set x. Then I'll write what, set y. Then I'll write what, set x comma y. I'll write it correct now, set x comma y. I'll write it. So in place of x and y, I have to just substitute 5. Okay, in place of x and y, I have to just substitute 5. So this will give me what, this will be equal to, so observe carefully, this will be 5 comma set of 5. Then y is what, again set of 5 already is there. So here y is what, set of 5. So set of 5 it will become. So this will become what, set of 5. Okay, set of 5 comma, this is what, set of x comma 5. Set of x comma y is what, x is what here, x is nothing but, what is this, we got x here, x is nothing but 5. Okay, x is nothing but 5. Set of 5 comma, okay, what is this, set of 5. Set of 5 comma set of 5 within the set, this entire thing under one set. So these are all what, these are all the power of d. So how to find out number of power of d? Number of elements, if they ask you to find number of elements in, if they ask power of d, if they ask number of elements in power of d, how you will write down number of elements in power of d? This is also very important concept. This is nothing but equal to 2 power n of d. Okay, 2 power n. Okay, 2 power, this is nothing but equal to 2 power n. If they ask you to find number of elements, see, this is the thing you have to remember. If they ask you to find number of elements in P of d, number of elements, or let me write it in the next page. If they ask you to find number of elements in the power set, number of elements in power set, this is the concept. Number of elements in power set, this is the concept. So see here, if they are asking number of elements in P of d, if they ask you, this is nothing but equal to 2 power n. Is nothing but equal to 2 power n. N is what? N is n of d. Okay, n is n of d. Okay, n of d is what? Number of elements in d. Number of elements in d is what? D is what? Null set. Okay, null set. So n of d will be equal to what? 0. So this will become equal to what? 2 power 0. So that is nothing but equal to 1. So if it is given like this, P of d, you will write it as what? 2 power n of d. What if they give power of d? Okay, so if you want to find number of elements here, number of elements of power of d, what you have to do? So that time what you should do? 2 power, how many p's are there? That many 2's you should write. So 2 power 2 to the power of what? N of d. To the power of what? N of d. Okay, to the power of what? N of d. Suppose they give power of d, or if they give power of d, if they give, okay, power of d, number of elements here also. So how do you find out? So here how many p's are there? 3 p's. So I should write what? 2 power. Here I should write what in the end? N of d. Here how many p's are there? 5 p's. 2 power. The power what I should write? N of d. Okay, now clearly observe. Okay, 2 power, n of d is what? N of d is 0. So this will become what? 2 power 0. This will become what? This one answer 2 power 0. Okay, this will become what? 2 power 0 it will become. So always you have to come like this you have to come, not the other way around. So 2 power 0 is what? 1. So this will become what? 2 power 1. So again 2 power 1 is 2 only. So we will get what? 2. So here what? 2 power 0 is what? 1. So 2 power, this one 2 power 0 is what? 1. So 2 power 1. So 2 power 1 is what? 2. 2 power 1 is 2. So 2 power 2 is 4 we will get. So number of elements in this power set. Now if you take this one, so this 2 power 0 is what? 1. So this will get it as what? 2 power 1. Now 2 power 1 is what? 2. So this will get it as what? 2 power 2. This you don't have to write these many steps. I am writing so that you understand. So this will become what? 2 power 1 is what? This is 2 power 1 is what? See here. This I can write it as what? 2 power. This is what? 2 power 1 is what? 2 itself. Okay. Now see this one. 2 power 2 is what? 4. So this will become what? 2 power 4. Now 2 power 4 is what? 16. We will get it as what? 2 power 16. We will get it as what? 2 power 16. So this is how you will get the number of elements in the power set. This is how you will get the number of elements in the power set. Okay. This is how you will get the number of elements in the power set. Now, if I talk about A, okay, if I talk about A, and there is set B, if I write this set B 2 3, definitely we can say B is a subset of proper subset of A, and A we can write it as what? A is a superset of B. You can write it like this. Superset we represent it like this. Superset we represent it like this. Clear? This is one thing you have to know. So number of elements in power set. Number of elements in power set. These are the things which you have to know. Now, certain things you have to know, basics. So what is this union? You must know. Union means what? Okay. Intersection means what? Intersection means what? Okay. Union means what? Intersection means what? Union. Suppose we are having set A given by 1 2 3. Okay. Set B given by 2 3 4. Okay. So A union B means you should write what? All the elements that are there in A and B. But if it is repeating, doesn't mean that you have to write it 2 times. You have to write it only 1 time. So this will become what? 1 2 3 4. Okay, you should not write, just because 2 is there 2 times, you should not write 2 times. Just because 3 is there 2 times, you should not write 2 times. Okay, you should write only 1 time. 1 2 3 4. Okay, 1 2 3 4. So for the same thing if I write, A intersection B. A intersection B means, this is what? A intersection B means what is common? What is common between A and B? What is common between A and B? What is common between A and B? 1 2 3 is there, here 2 3 4 is there. What is common? 2 and 3 are common. So this I will write it as what? 2 comma 3. So in the Venn diagram, how do you represent A union B? Suppose this is set A, this is set B, this is set A, this is set B. A union B, A union B, how do you represent? A union B, you will represent it like, so we are having everything here, this having everything here. So usually you represent it like this. So A union B is this one, A union B is this one. Similarly, if I want A intersection B, A intersection B, if I want A intersection B, this is set A, this is set B, this is set A, this is set B. So A intersection B is what? We have to write only the common things. We have to write what? Only the common things. That means what? This is representing A intersection B. This is representing what? A intersection B. Clear friends? This is representing A intersection B. So A union B, A intersection B, we have learnt. Okay. So these are the things you have to remember when it comes to the sets. So there is one this law called De Morgan's law and some properties. Okay, so De Morgan's law and some properties are there. Okay, let me explain that. De Morgan's law means what? And properties. So De Morgan's law, what does it say? De Morgan's law, let me write it here. De Morgan's law. Just make a note of it. Highly useful in sets and relations, but especially useful in probability. De Morgan's law, what does it say? Certain properties you have to write down. So A union B complement can be written as what? A complement intersection B complement. Make a note of it. This is first thing. Second one, A intersection B complement can be written as what? A complement union B complement. This is De Morgan's law. Some formula you have to know. Some formula. This is not related to De Morgan's law. Suppose I write A minus B can be written as A minus A intersection B. This can also be written as what? A intersection B complement. A intersection B complement. Next one, what you have to make a note is B minus A. If I write it, this is B minus A intersection B. This can also be written as B A intersection, or you can write it as what? This is what? B minus A, right? So B intersection A complement. So 1 2, this is another 1 2. These formulas, this is related to De Morgan's law. These are some basic formula related to sets. So we learned what is set, subset, power set. Okay, number of elements of a set, number of elements of a power set. All these things we learned. Okay friends, all right, we'll wind up now. Let's meet in the next session where we'll be discussing about intervals and also wavy curve method. All right friends, thank you. Let's meet in the tomorrow session. Please take care.